So I have, today we're going to be implementing the linked list itself, and we're going to be using our node class we implemented last time. Okay. Um, so what is a linked list exactly, and what does it look like? Sorry, I was recording earlier and it did not record at all, and I spent about an hour, I think, just working on this, explaining everything. So here we go again, part 2 or take 2. Anyway, so a singly linked list is a data structure that it's kind of like an array, but it's dynamic, and you have a sequence of nodes. Each node has a pointer to a next node and a value. Just like we programmed last time, our node had data and a next pointer to our next node. So usually we have two, in our linked lists, we have 2 pointers. One to indicate the start of the list and one to indicate the end of the list. We call them usually head and tail. So this is what it how you would represent a linked list artistically, I guess you could say, with a diagram. This would be considered our head, and it points to a node. This is our node right here. It has value and next. And if you look at these numbers and these numbers, this is how it would look in code. Okay? There are many types of linked lists, but today I will be just talking about singly linked list. So we can only go in one direction, which is forward, not backwards, like in doubly linked lists. We might look at them later on, but we'll see. Okay. So the only way to traverse a linked list or singly linked list is one way. We have to start from the start all the way to the end. If we had a doubly linked list, we can start at the end and go all the way to the start. So I created the header and CVV file from last time, and we're gonna start with public. And the first thing we're gonna do is our constructor. Here we are just going to initialize our pointers. This one is our destructor, and here we are going to handle deletion of nodes that that were left in the program. Otherwise, we are going to have memory leakage. So we're also going to have a insert function, and this will take in a value, an integer type, and this is where we're going to be inserting our data here, and then we're going to be storing it in the list. Make sure that this variable type is the same as this variable type. Later on, I'll be implementing. Damn it! I keep doing it. I keep doing it. Later on, I will be implementing how to dynamically change the data type of your linked list. Kind of like vectors. How vectors, if you ever used the vector data type that it's in the standard libraries for C and C++, it's similar to that. You just use a template. Anyway, so after our insertion, oh yeah, we're actually going to print our data so we can actually view if it's working, so we don't have to code and code and code and then find a problem afterwards. It's usually good to work in small chunks and then test regularly. So this one is insertion of nodes to list. Alrighty, let's go here and so here we're just, oh yeah, I forgot some stuff. Actually, we can't do that if we do not have this. So this is our head pointer to the node, the first node, and this is our tail pointer to the last node. I like to do it like this better. And we will also have a size to keep track of our list. So here, all we have to do is say tail equals head equals null pointer or null, and initialize our size to 0. You can initialize it to -1 or whatever you want, like 0. 0 is the loneliest number. Okay. Our destructor. Here, like we said before, we are going to delete every node that we have left. So the first thing we should do is to check if we have any data in our list. To do this, we always check the head pointer. So if it's not null, then we have data. We might have 1, 2, maybe 3, or 4, or a lot, or infinite numbers. So after this, we one U, 2 R's, dummy. We get a temporary variable, call it current, and we're gonna store the first item of our list, and then actually after this, then we're gonna go into loop, and we are going to as long as current is not null, then we want to keep looping. And here we want to set another variable. We'll call it next, and next is going to be storing the next item on the list. If we don't do this, and if we don't store the next item and we delete this, since we only have one way of knowing where the rest of the list is by our next pointer, if we delete our current pointer, the rest of the list goes bye-bye. It is still in memory. You might have hundreds of data all just gone because you don't have access, you don't know where it is in memory. That's why we store the next node. And then after we have the next node secure in a little place, we can now call delete on the current node. And then we want to set the current node equal next to keep looping. Once we are done looping, once this is null and this is null, we get out of the loop, and all we have to do now is just set our variables to null. That's it. Since we do have a variable to handle the size, since we're going to be deleting this list by the time we get here, we don't really have to yeah, we don't really have to do that. It's pointless. I was going to say we should decrease this, but we're deleting the whole list, so we don't need to. We're not ever going to see that again. So the next thing on our list, anyway, insert, and it returns a boolean. Bool list insert int data. Boom. So the first thing we do here is we want a temporary variable, and I'll explain exactly what you have to do in order to insert something into a list. Okay? So let's get that and delete some of this stuff. What we are going to be doing here in this function, we're just going to be inserting something at the end of the list. And this is pretty simple. So the first thing we want to do is make our temporary variable. Ta-da! Okay, and then insert data into it. Data. After we've got the data in here, we got another pointer called t or tail right here. So what we want to do is we want to get this link and link it to the temporary temporary node that we just created with our data. And then after this is created and linked, we want to move the tail over here to keep track of the last node in our list. And this will obviously be null. Okay? So to do this is pretty simple, actually. So first, we create a pointer. Well, new we have so first we insert the data here and null pointer here. Okay, well, first we make an instance of our node. We make a new object and we insert data and make sure that the next pointer is null. After that, we check to see if our head is empty or not. If it is empty, then it's the first node in the list. Sorry, I just went blank. So we want to set head and tail to temp. And it's easy as that. We want to increase our size and return true. If it's not empty, then we just want to insert it after tail. And this is pretty simple. We just say tail next, or get next, actually set next. We set the next pointer and we insert temp here. After that, we gotta move our our tail to the end. So we do tail get next. This shifts the pointer tail all the way to the end, and then we are done. We return true as well, and we increase our size. If none of those two were met, then we just return false. And that's how we insert something to the end of the list, at least. There's a lot of ways of insertion. There's at the front, well, actually two for singly linked lists, at the front and at the end. And it makes sense to do it at the end for me. So I'll be doing it like that. Later on, we will implement the other type, which is in the front, and maybe we'll also get into sorting the list. We will. Sorting algorithms are part of data structures, and I want to go over pretty much everything that I know in data structures. Anyway, so now we're gonna print. We've done enough code that we want to check to see if it's correct or if it's not correct. So we're gonna implement a print function to loop through every node in our list and print out its data. So we create a temporary node. First we check to make sure that we have something in our list. Remember, if head is not empty or not null, then we do have something in the list, at least one node. So we only want to do something if we have something in the list. Otherwise, we're gonna encounter errors trying to access pointers that are null. Okay, and then we start at the head, and we are going to loop and print each one until until temp is null. And if it's not null, then we are going to increase or traverse through the list. And all we do here, see out, say node data, and just print out the data, get data, and we end the line. And that's it. That's it for printing. Now let's see if it works. So I've included here our list and our stream, and we're using namespace std just like we did on the previous lesson, except now it's linked list header file. So we create a list, and we are going to insert 10 random well, not random, 10 numbers into this list to see that it works. So after we insert all of those, we want to print. Remember, we don't need a loop for this outside because we already have an internal loop inside of the print function. And then after that, we just pause the program so we can actually look at it. And after this, we are going to check that we actually created a list. If we did create a list and it's not empty, then we want to delete the list. This will trigger the destructor and it will delete every single node that we made, since we don't have a way to um, remove anything yet. We'll just delete them in the destructor to avoid any data leakage or memory leakage. I keep saying data. Anyway, after that, we want to set this to null. Doesn't really matter because we're going to end the program here. But let's check it out. Yeah. Okay. Let's run this. Okay. So as we can see, it actually created 10 nodes, and from 0 to 9. And yeah, it works pretty good. So I'm gonna stop here. If you guys have any questions, comments, concerns, let me know. If you like this tutorial, if it was informative for you, and if you want to continue learning more, feel free to subscribe to my channel. I will, like I said before, I will try to do at least one every week. I do not guarantee that because I have a lot to do for school. And yeah, if you guys have any things you want to learn besides this, let me know and I'll see if I can do it. All right. Thank you. Have a great day.